Hi guys, in this section 5.3, we focus on a few properties of logarithms. The good news is we don't have too many. If you skim through the section, this is the first one, the change of base theorem, and then we have a few other more. There are property, products property, quotient property, and power property. These properties are meant to uh, simplify more complicated problems into simpler problems so that you can solve the more complicated problems in a simpler way. Now, let's take a look at the first one, the change of base theorem. So this is the more general version. So this is the change of base theorem. If you want to, oftentimes I encourage students to try to describe some results using their own words. If you are able to do that, that means you kind of understand what's going on here. So if I look at this theorem, the left side log base a of x is equal to, on the right hand side, is equal to a ratio of two logs, right? So the top is log base b of x, the bottom is log b of a, and then you do see that x goes on top, a goes to the bottom. That's the pattern that you see. And this b is any number that as long as it's greater than 0 and not equal to 1. So what's nice about this property? This property is saying that you can convert any log uh, function into any base that you want. So b is the new base, right? So this is why this is called change of base theorem, because you can change this base. Originally it's a, now you can change to any value, any other base. Uh, what what is nice about this one? Um, Oftentimes, some base A may not be that nice to work with. So if you want to convert this base into another base that's nicer, then the problem is easier to solve. And what are the nicer bases? This is the first one. Okay, when the base is e, the natural, we introduce this number, it is about 2.718. So this is the one irrational number, e. So when you change that to e, let's take a look at what will happen, okay? So log a of x should be, now if you look at this expression, it's going to be log b is e, right? So log base e of x. If you remember that we actually have a new notation that's a natural log of x, right? So therefore, the top becomes natural log of x. The bottom will become to natural log of a. So therefore, this log base a of x should be natural log of x, natural log of a. So this is the new result, the most important one. Now this is one special case. I mentioned that there are a couple of different special cases. So that's the first special case. Another special case is when b is equal to 10. Okay, when b is equal to 10, this is so-called common log. In this case, your log base a of x is equal to log, I'm sorry, it's no longer natural log, it's common log. So log of x, log of a. Okay, so these are the two new special cases that you want to focus on. So yes, now let's apply the change of theorem to evaluate the following use both base e and base 10. So let's take a look at the first one. So when we use, I have to do it twice, right? The first one is use the natural log base e. The other one is use base 10. So for the first one, it should be natural log of 8 over natural log of 3. So therefore, this will be the exact value if you use your calculator. So you can use your calculator to try to evaluate both and then find the quotient. I'm going to do that soon. But for the second one, if you use common log, then the log of 3, log base 3 of 8 is going to be common log 8 over common log 3. So, and then of course we are gonna evaluate these two numbers and then find the ratio in our decimals. But this is what we are gonna what we are trying to do for this problem. Now I'm gonna go to my decimals site to do the algebra. So now I'm on my decimals. So to find those two values, you're gonna type in natural log of 8, right? Just type in natural log of 8, and you already see that it is approximately equal to 2.079. And then you can continue to divide by natural log of 3. So this gives you 1.89, about 1.893. So let's go back. And therefore, I do know that, so when you do natural log of 8, natural log of 3, this is about 1.893. Okay, so let's check the common log. We did that common log here. So it's common log of 8 over common log of 3. So let's check in decimals to make sure that they are actually equal. So let's go back to decimals. Here, I'm going to type in common log, which is log. Just type common log of 8 divided by common log of 3. So you do see that they are equal right here, okay? So that's a quick exercise using this change of base theorem. And obviously, my second, the part B is kind of like, I don't know why, I kind of make a typo. So that this is supposed to be my A, this is supposed to be my B. You can just quickly delete the bottom one. Now let's look at some new properties, okay?